Hello everyone, this is Rashaka Janjarla. I'm an educator in Unacademy. You can follow me on Unacademy Learning app where you can find other courses as well. In this lecture, we are going to discuss about the rolling contact bearings. And please rate, review and share the video and also subscribe to Unacademy YouTube channel. Welcome again to rolling contact bearings. Bearing is a mechanical element that permits relative motion between two parts such as shaft and the housing with minimum friction. So these bearings are the friction eliminators. Okay, the term rolling contact bearings, anti-friction bearing and the rolling bearing are all used to describe that class of bearings in which the main load is transferred through elements in rolling contact rather than in sliding contact. So these rolling contact bearings are used to transfer the load from the elements in a rolling contact to the other elements of the mechanism. Okay, so these rolling contact bearings are very useful for the anti-friction. Okay, anti-friction applications. That's why they are also called as the anti-friction bearings. And rolling bearings are the rolling contact bearings. Okay, so in rolling bearing, the starting friction is about twice the running friction, but still it is negligible in comparison with the starting friction of a sleeve bearing. Okay, these rolling contact bearings are very much useful for providing the anti-frictional joints. Okay, so the friction, the starting friction, which is the static friction for this rolling contact bearings, is twice the running friction, that is mu k and mu s, where mu k is the coefficient of kinetic friction and mu s is the coefficient of static friction. Their values are different, and here the mu k value, the coefficient of the kinetic friction, is half of the coefficient of the static friction. Okay, so this is the useful property of the rolling contact bearings, as they provide the anti-friction joints. Okay, so the load, speed and the operating viscosity of the lubricant do affect the friction characteristics of the rolling contact bearings, and in designing the bearings, bearing specialists must therefore consider such matters as fatigue loading, friction, heat, corrosion, resistance, kinematic problems, material properties, lubrication, machining, tolerance, assembly use and cost. So in designing rolling contact bearings, we have to consider all these effects, and with the help of these effects only we can find a safe design of the rolling contact bearings. Now we are going to see how to find a useful bearing which can resist all these values, all these loadings on that bearing. Okay, so in this lecture we are going to see the general types of rolling contact bearings, and in the next two lectures we are going to discuss about the types of bearings. Okay, so here we have the bearing types. Bearings are manufactured to take pure radial loads and pure thrust loads, and the combinations of the two kinds of the loads. Okay, so the nomenclature of the ball bearings is illustrated in the figure, which also shows the four essential parts of a bearing. So in this figure you can find the outer ring and the inner ring and the bore diameter and the corner radius, shoulders and the corner radius, and also the outer diameter and the face, the outer ring ball bearing, ball separator, and this ball separator is used to separate the balls in between the two rings of the ball bearing. Okay, so on separating the balls of the bearings, they will decrease the friction between the adjacent balls in that bearing, right? So this separator is very useful for removing the friction, eliminating the friction between the balls in that ball bearing. Okay, so this separator is used in most of the application to reduce the friction between the balls of the ball bearing. So the nomenclature you can see here, the separator and the outer ring and bore, which is this is the bore, and you can see the other nomenclature used to describe the ball bearings, rolling contact ball bearings. Okay, so some of the various types of standardized bearings that are manufactured are shown in the figure. Here you can see the deep groove, filling Bosch, angular contact, shielded, sealed and external self-aligning ball bearing, and these are the cross-sectional views of these bearings. And also we have the double row bearings. This is double row and self-aligning bearings, and also the thrust bearings, and here you can see the self-aligning thrust bearing. So according to the application, according to the requirement, we have to select one of these bearings and they will provide the desired applications. Okay, so see here we have various types of ball bearings in this figure. So I'm going to discuss about these ball bearings in the later discussions about these the types of ball bearings, and I'm going to discuss about the applications and their properties. And these ball bearings are designed to take the radial and also thrust load or combinations of radial and thrust loads. Okay, so the single row deep groove bearing will take radial load as well as some thrust load. So here you can see, here we have the single row deep groove ball bearing which is used to take the radial loads and also the thrust loads. When this bearing is connected to a shaft and some of the components in that application, these bearings can take the thrust load that is applied by the components and also by the shaft. Okay, so these different types of bearings are discussed in the later course lectures. So here we have some of the large variety of standard roller bearings are available, are illustrated in the figure. So in this figure you can find the large variety of standard roller bearings. So these are the ball bearings where the rolling elements are balls, right? So in this type of bearings we have the rollers which are in cylindrical or conical in shape. They will roll and they will provide the frictionless joint in that bearings. Okay, so straight roller bearing figure A, this is the straight roller bearing, will carry a greater radial load than the ball bearings of the same size because of the greater contact area. So see here, if you observe this, which is called as a straight roller bearing, this is in the figure A, straight roller bearing will carry greater radial load. Okay, then as you can see here we have the ball bearing which is deep groove ball bearing, and the contact area for deep groove ball bearing is less than the contact area for the straight roller bearing here in this figure A. Okay, that's why these straight roller bearings will carry a greater radial load than ball bearings of the same size because of the greater contact area. Okay, so here we have the applications of the ball bearings, roller contact ball bearings. The spherical roller thrust bearing in this figure B is useful where heavy loads and misalignment occurs. The spherical elements have the advantage of increasing their contact area as the load is increased. So next we have in the figure D we have needle bearings. These are the needle bearings where the rolling element is looking like a needle, right? That's why we call this as needle bearings, and they are very useful where radial space is limited. So if we have the space limitations, we have to go for the needle bearings because they have, as you can see, their size is very small as compared with the other roller bearings. So where we have the space limitations, we can go for these needle bearings, and they have a high load capacity when separators are used, but may be obtained without separators, and they are furnished both without the races. And see here, they can take a high load capacity. They have a high load capacity and they can take the radial loads, and if we use the separator, which is the separator between the elements of that bearing, they can provide a high load capacity. Okay, the taper roller bearings in the figure E and F, these are the taper roller bearings, and their application is they combine the advantage of ball and straight roller bearings, since they can take either radial or thrust loads or any combination of the two loads. And in addition, they have the high load carrying capacity of straight roller bearings, and the taper roller bearing is designed so that all elements in the roller surface and the race face intersect at a common point on the bearing axis. So see here, these taper roller bearings are used to take the thrust load and also the radial loads on the joints. And the taper roller bearings is designed so that all elements in the roller surface are intersect at a common points in the on the bearing axis. Okay, so these are the applications of the the roller bearings, and you have seen the rolling contact bearings where we have used here. These are the ball bearings and these are the roller bearings. Here we have the roller and here we have the balls, right? That's why we call these as ball bearings and these as the roller bearings. So now we are going to in the next lectures you are going to see the different types of bearings, rolling contact bearings, and their applications and their advantages, and in which purpose we have to select one. You are going to see how to select the suitable bearing for our application. Okay, thank you.